Hi everyone. So my name is Bello Abdulaziz and I'm the founder of H.E.A.T, meaning AZ Electronics Academy of Technology. So in our last class that we did on Sunday, we discussed about some basic components in electronics like the resistor and the LED. So in the last class also, I discussed about the fact that when a resistor is connected in a circuit, we have two connections, which is the series and the parallel connection. We just did a brief introduction to it, and we also use my multimeter to do a live verification of the theory of series and parallel connection. So that's why we are about that, and if you want to watch the video about it, like and comment in the comment section. So now, in this particular question, we were given this task. And the task was to do what? To find for the current flowing in this particular 8 ohms resistor. What's the question? Find current in 8 ohms resistor. And the voltage flowing through the circuit was 12 volts. So now, how are we going to solve this? Don't worry, I'm going to be breaking it down and showing you how this question is going to be solved. Very simple. So now in this question, and in the last class, I discussed about what we refer to as current, and current symbol is I, and the unit is what? Amps. And I also discussed about another thing called voltage. Voltage is V, which is called a voltage V, unit is in V, like 10 volts, 20 volts, and so. So now, in this particular circuit diagram, we are going to break it down because in this particular diagram, we have two types of connection here. We have the series, and we also have the what? Parallel connection. And in my last class that I did on Sunday, I discussed about it that in a series connection, the resistors are being connected on a straight line. Like for instance, let's assume this is resistor 1. This is the first pin, this is the second pin. And this is resistor 2. This is the first pin, this is the second pin. So in a series connection, it's done in such a way that the resistor 2 and the resistor 1 are connected together, while this pin 1 and pin 2 are left as our output. So now it means that this resistor, let me label it R1, R2, R3, and R4. It means that what? It means that R1 and R2 are what? Connected in series, while R3 and R4 are connected in parallel because of what? There is a junction. This is the junction here. There is a junction. So now we're going to be doing something fun and interesting here. So now for us to calculate the total resistance for R1 and R2. Total resistance for R1 and R2. We should be considering the fact that these two resistors are connected in a series connection. And in my last class, I said that if your resistor is connected in a series connection, then total resistance, that means RT, is going to be R1 plus R2. If you know how to calculate this value, you can pause the video for now, calculate your answer while I also calculate mine, so you can see whether we can get the same answer. So now, what's our R1? Our R1 is equal to what? 4 ohms. What's our R2? Our R2 is equal to what? 2 ohms. So it means that our total resistance RT is equal to 4 ohms plus 2 ohms. So total resistance here is what? 6 ohms. Now what does 6 ohm mean? 6 ohm means that if you calculate the total resistance for this whole area, here, we're going to be having what? are going to be having 6 ohms. 6 ohms. And one thing about when a resistor is connected in series connection is that if your resistor is connected in series connection, this voltage passing through it is going to be different. The voltage passing through here, Vx is going to be different from the voltage passing through here, Vy. It's going to be different voltage. But the current passing through is going to be the same thing, moving from here to here. That is the thing about the series connection. That means what? In a series connection, current is constant, while the voltage varies. Now the voltage is going to be different based on the resistor value. But for a parallel connection, reverse is the case. For a parallel connection, V is constant, while I varies. And the reason why the I varies is that the moment the current should reach this place, it's going to get splitted. It's going to move to this place and also move to this place. So that's why the current is going to change. But the voltage here, the voltage at this resistor is going to be the same voltage in this place also. So now we have that our total resistance for R1 and R2 is what? 6 ohms. Now let's calculate the total resistance for R3 and R4. Total resistance for what? Total resistance for R3 and R4. So total resistance, because of it is a what? Because it is a parallel connection. In the last class I did, I showed how the formula for total resistance in a parallel connection is being derived. But to avoid losing much time on it, let me just jump straight to the formula. RT is equals to R3 times R4 over R3 plus R4. So now what do we have? We have that if you know the calculation, you can pause the video and solve it yourself. What our R3? Our R3 is 6 ohms. R3 is equal to 6 ohms. R4 is equal to what? 8 ohms. So now let's do the calculation. R3 is 6 times 8. Though my calculation might not be really perfect like that because I'm not with the calculator now, but you can calculate it on your own. So R3 6 plus 8, so that's going to be 48 over 14 ohms. So let's break it down. So 14 in 48 is going to be 3. 14 times 3, that's 42, remainder 6. So 6, I think that are going to be 14 times 4, 6, 56.4, 56. They are going to give us something like this: 56, 64, 14 times 2, 28. So we are having like 3.42 ohms. In yours, you might have 3.43 or so. I don't think the rough calculation here. So it means that what? It means that the total resistance, if you combine these 6 ohms and 8 ohms, if you combine it together, you're going to be having what? 3.42 ohms. And also in the class I did the last time, I demonstrated it live with my multimeter. I used the resistor and the resistor here, calculated it with the main mass calculation, and also did it with my multimeter. So now what do we have? We have it that total resistance here is 6 ohms, and total resistance here is what? Is 3.4 ohms. So I'm coming. So it means that the total resistance in the whole circuit, total resistance in the whole circuit will now be this. I've already combined all of this together. 6 ohms. Now this 6 ohms is demonstrating the whole of this resistance plus the total resistance of this place also, which gave us was 3.42. 3.4. Let me use 3.4 ohms because of calculations. So we bring it like this. And mind you, this long line is the positive of the battery, while the short line is the negative of the battery. So total resistance is equals to 9.4 ohms, while voltage is equals to what? 12 volts. So now, before we can calculate the current flowing through this 8 ohms resistor, we need to calculate the total current flowing through the whole circuit. That means this I.T. When we calculate the total current flowing through the whole circuit, I remember from Mr. Ohms, he said that V is equals to IR from his law. So VT, that means the total voltage, total current, total resistance in the whole circuit. So total current is going to be VT over RT. So total voltage is 12 volts over total current, that is 9.4. That should be around let me just say 1.2 amps. I don't really know the value right now. Yeah, 9.4. We're going to be left with coming 12, 0, 9.4. 6 to 2.6. Let's just leave it like that. 1.2 amps. Although it might not, this is just an estimated value. You can calculate it yourself also. So it means that the total current IT from my own calculations, which is an estimated calculation, is around what? 1.2 amps. I don't want to rub up this place because we're going to need it. Now, let's now go to the main question we were asked. Let's go to the main question. Now, what was the main question? The main question told us that we should look for the current flowing through this 8 ohms resistor. But there's not something interesting happening. Since the total current flowing through the circuit is what? 1.2 amps. It means that it's flowing like this. Flowing like this, flowing like this. It is still the same 1.2 that is flowing through here. Because I said that in a series connection, the current is constant. 1.2 that is flowing through here, 1.2 that is flowing through here. But the moment we get to this place, something is going to happen. The current is going to what? The current is going to split. One current is going to go here, current A. Another current is going to go here, current B. Can you see? Because of the fact that the resistors are connected in what's parallel, the current is going to get what? It's going to get splitted. So that's how it introduced us to late Mr. Kirchhoff, which we call KCL. That means Kirchhoff current law. And his law was that the total current flowing through a circuit at a particular junction is the same total current leaving the circuit. So it means that total current IT is equals to IA plus IB. And now if you look at it, you see that the total current, the IA is representing the current flowing through the 6 ohms. So it means that what? IT is equals to what? 6I6 plus what's B? The B is representing the one for 8I8. Okay, so now this is now where the thing is now going to look a little bit messy, because we know the value of our current, which is 1.2 amps. Total current. We don't know the value of the current flowing through the resistor. We don't know the value of the current flowing through the resistor of 8 ohms. And we're looking for this especially. But thanks to the fact that KCL combined with ohms. These two guys, they combine together and gave us a very beautiful equation. KCL, that is Kirchhoff current law. It was not that I was able to propound this law. Total current is the same leaving and entering. But ohms also told us that don't forget that voltage is equal to what? IR. And this is how the thing now look a little bit interesting. The total voltage is equal to what? Total current times the resistance. Let's say RA for this parallel circuit. And VT is equal to what? IT, total current again, times RB. But if you can remember, I said this earlier that in a parallel connection, the voltage are the same thing. That means voltage is constant. So it means that the voltage flowing through here is the same thing as the voltage flowing through this place. So if that is the case, it means that the voltage and this voltage are equal. So it means that these two equations, equation 1 and this equation 2, are going to be equal. Why? Because of this and this are the same thing. If this one is 2 volts, this one also going to be 2 volts. So let us now equate it. We have IT RA is equals to IT RB. So now, since we have this formula, IA RA is equals to IB RB, and we know that A from here is meaning 6. So I6 R6 is equals to I8 R8. So since we are looking for IB, you cannot easily make IB sort of formula A, because if you make this sort of formula A, you're going to get cancelled out. So I'm going to make I6 the sort of formula. I6 is equals to I8 R8 over R6. So it means that if we go back to this Kirchhoff law, we're going to substitute this place. So we are going to remove this I6 away and put this one there. So it means that IT, total current, which we now has 1.2, and from our own estimation, that might not be the real result of the calculator, but I just like to estimate like that. Is equal to what our I6 now, we are replacing it with this. I8 R8 over R6 plus I8, and our I8 is our main objective. Now let's add some little mass. So IT is equals to, this is common factorize, I8 1 plus R8 over 6. What I usually do here is that if you multiply this I8 times 1, I'm going to get I8 back. I8 times R8 over R6, you get this back. I just decided to factorize it. So let me solve what is inside here. So IT is equal to I8 over, the LCM is R6, R6 plus R8. So now since we're looking for I8, we're going to divide both sides by what? This whole formula here. So that we're going to make I8 stand on this one. So it means that I8 is equals to IT over R6 plus R8 over R6, which is the same thing as IT divided by R6 plus R8 over R6. But it's going to look a little bit messy if we calculate it like this. So let's change division to multiplication. And for that to happen, we're going to look for the inverse of this. That means take R6 up and R6 plus 8, we'll take it down. So I8 is equals to IT times R6 over R6 plus R8. So now what is the resistance of R6? Which is what? 6 ohms. Sorry, I'm using 6 here. I just decided to use 6 because those are the resistors we are using, 6 and 8. So I8 is equals to, our total current is 1.2. as I said earlier, for my own estimation, and I repeat, you might get something different. 1.2 times R6 is what? 6 ohms. 6 over 6 plus 8. So that's going to be 1.2 times 6 over 14. So 6 over 14, 6 over is going to be 1.2 times 6 over 14 should give us 0.42 based on my own estimation. So I8 should give us around 0.5. It should be an approximate. You might get 0.55, you might get 0.56, but my own estimate answer is for 0.5 above amps. So that's our final answer to this question that might look a little bit complex. So it means that out of the whole resistor here, 4, 2, 6, and 8, the total current flowing through this resistor of 8 ohms is what? 0.5 ampere. So that is it. If it is for the 6 ohms, since I.T is equals to I6 plus I8, then for the I6, it's going to be I.T minus I8. And what is the I.T? 1.2 minus this. So for the I6, though we're not asked, we're going to be having around 0.7 amps. So that is it. So that is it about it. So the total current flowing through the circuit is what? 1.2 amps. But the current flowing through these 8 ohms exactly is what? Approximately 0.5 ampere. So now, I've been saying it earlier that in my previous class, yeah, I have a class that I do teach basic electronics, and in the last class, we discussed about resistors, LED, and so on. So if you want to join the class, just say it in the comment section, and I'm going to join you. And the fee is just 500 naira. But it is limited, meaning that the price might soon increase. Once the slot for 500 naira is filled up, and you are late, the price is going to get increased. So thank you for watching it, and I hope you enjoy the video. Bye.